Assalamu alaikum class. I hope all of you are fine. So today we are going to start the one question of the regarding the law of the exponent. In these questions we will almost discuss all the laws of the exponent and we will do the practice of these laws. Okay, so I'm going to start the question number 5 of exercise 1.2. Okay, so the question is in front of you. So boys, you can hear here, you can see here they are saying that use suitable laws of the exponent to show that. So we have to prove something. So first of all, I am taking the left hand side here. Now we will start solving the brackets. So you can see here inside the bracket there is one quotient. So first of all, we will use here the one law of the quotients, the quotients law of the exponent. We know that if x am over an, two quotients there, the one quotient is here you can see that the base is same. So the rule is we will write on the base one time and we will subtract the exponents in this way. So same rule I will apply on this bracket. So it will become x p minus q into p plus q. Same we will do here in this inside this bracket. So y q, and this exponent will when will go in the numerator, so it will become minus r. It's an application of this quotient law of the exponent, quotient rule of exponents. So I am using this rule here. Then the same thing I will do here. Z r minus p into r plus p into x q square y r square into z p square. Okay, I hope so that is clear to you. Now we will use the next law or rule, which is the power of power rule. The power of power rule. What does this rule states? Let's suppose that we have one term a raised to power m raised to power n. Then the simple rule is we will simply multiply both the terms, both the powers. So it will become a m n. So same thing I will do here, the p minus q and the p plus q. So I will multiply p minus q with p plus q. And here boys, you can see here we can use one identity here. The one formula we can use here, a plus b into a minus b. So it will become a square minus b square. So I will use this formula here. So it will become x p square minus q square multiply by y. You can see here q minus r, q plus r. So it will become q square minus r square. Then z r square minus p square multiply by x q square into y r square into z p square. So students, you will see here we use here the three different laws of the exponents, the quotient law of the exponent, then the power of the power rule, and the one I will use here the formula which is a square minus b square. Now I am going to use here the one more formula. Here you can see that we have the different terms and all these algebraic terms are multiplying with each other. Now how can we combine them? Now I will use the one more law of the exponent, which is the product rule of the exponent. Product rule of exponent. This product rule states that if let's suppose that we have a raised power n one term and a raised power m is another term. You can see here the base is same. If the base is same and two algebraic terms are multiplying with each other, then simply we will write down the base one time and we will add the exponents of these terms. So same rule I will apply here. You can see here boys, here it is the x square, x is the same base and this x is also the same base. So simply what can I will do here? I will just simply add these terms. So x p square minus q square plus q square. Then in the next step, that is the y raised to power q square minus r square, and that one you can see here y r square. So I will add these two terms. So q square minus r square plus r square. Then z and this one, these two terms are also multiplying with each other. So I will write down the base one time and add the exponent. So r square minus p square, and here the exponent is p square. Now you guys, you can see that q square minus q square, these will be cancelled, minus r square plus r square minus p square plus p square. So after cutting this, we have the result now, x p square into y q square into z r square. So you can see here the question states the same thing. So we can simply say that hence proved. I hope so. The laws of the exponents are clear to you. Okay, goodbye class.